Hello everyone. Today we're going to be doing one of these games. We're going to be doing the Epoxide Hydrolysis game. So let's get right into it. So for this one, we have Epoxide Hydrolysis to glycols, that's base-catalyzed, which is the top one. And then we also have Epoxide, which is this guy right here, Hydrolysis to glycols, which is acid-catalyzed. And as we can see, we have the acid right here. So first things first, let's do the top one. So we have hydroxide, which is going to act as the nucleophile. This epoxide is going to act as the electrophile. So we're going to do an SN2 reaction where we have the nucleophile in the form of the hydroxide attacking the least substituted position on this epoxide, where this oxygen will be the leaving group. So now we see that we have the curved arrow notation for this. So after that happens, we have this hydroxide adding to this position right here. And we also have an alkoxide, since we have this oxygen with its negative charge and one bond and 3 lone pair electrons. So now, since we have water floating around in the reaction, which you can see him again right here, we're going to have one of the lone pairs deprotonate the water. So we have created our glycol, and we've also reformed our hydroxide. So this sodium is the spectator ion. It's been here the whole time, and we can see that it's base catalyzed because the base, we start off with the base, and the base is then reformed by the end of the reaction. So, likewise, when we do the acid catalyzed epoxide hydrolysis to glycols, we will start off with this hydronium, which is our acid, and we will end up with hydronium again. So in the case of the acid catalyzed reaction, we see we have our epoxide with these 2 lone paired electrons. So one of the lone pairs is going to deprotonate our hydronium because we know that the hydronium is the proton donor. We see the curved arrow notation for that. Now we have a positively charged oxygen right here in our epoxide, and we have water, which was formed from the hydronium, but is also floating around in solution since it's an aqueous solution of hydrochloric acid, as you can see. So we are going to have this water attack at the more substituted position, and then this positively charged OH is going to be the leaving group. So now we have this water added to the epoxide, but there's one thing left that we need to do. We need to deprotonate this OH2 so that it's just the OH. So since we have water floating around in solution, we are going to deprotonate. We have the curved arrow notation for that, and then we are left with our acid that we started with, and we're also left with our glycol. So I'm going to be leaving links to all the reactions on the reaction list and also to this specific one in the description. But if anyone has any questions, please feel free to leave them in the comments below. Thank you, and I'll see you in the next one.